video is going to take a look at how to use the Pythagorean theorem to solve word problems. So if you'll take out your notes packet and turn to this page, we'll get started. The most important thing with both Pythagorean theorem and, as you'll see with trigonometry problems, is to draw a picture. The picture need not be exact in terms of the situation, but it should be exact in terms of the math that's going on. So the latter problem is your very typical trigonometry or Pythagorean theorem problem, and it says a ladder 17 feet long is placed 8 feet from the base of the house. Now you need to think about what's going on. The ladder is what's leaning against the house. And here's your house. And it says the ladder's 17 feet long. It's 8 feet from the base of the house. And we want to know how far up the wall the ladder will reach. So it's very important to draw the figure accurately in terms of placing your distances in the right section. Now you can use Pythagorean theorem to solve that. In fact, it is a Pythagorean triple, but just to get used to showing your work in the correct way, the first thing you will do is you will write the Pythagorean theorem down. And you can write either a squared plus b squared equals c squared or c squared equals a squared plus b squared. In this case, we're not solving for c. So I'm going to plug in my 17 squared equals 8 squared plus b squared. Now you could put x squared there, or you could use a squared, plug in the 8 for b. That part doesn't matter. The essential part is getting the hypotenuse in the right place. So what's going to happen here is we are going to simplify and solve, and you can go ahead and do that. You don't need me. So we would get that x equals the square root of 225, or 15 feet. And you should be answering in units. Number 2, your boat drifts away from the dock 3 miles south and then 4 miles east. How far away is your boat from the dock? Well, I'm just going to label my dock with a D, and I'm going to go 3 miles south, 4 miles east. And I want to know how far away is my boat from the dock. So here's my little boat. I don't know how far away I am, so I would solve that. Again, another Pythagorean triple. In this case, I am solving for the hypotenuse, and it's the sum of 3 squared plus 4 squared. Take the square root of that, so you would get the square root of 25, and x equals 5 miles. Important to know your directions also, north, south, east, west, and how that would look on a map. Chris rides his bike 9 kilometers south and then 8 kilometers and then 12 kilometers east. How far is he from the starting point? So I'm going to leave that one for you to do since it's very similar to the last one. I'm going to go on and take a look at number 4. Also a very classic Pythagorean theorem or trigonometry problem. Laramie is flying a kite which is 16 feet from the ground. So when they're talking about the kite being 16 feet from the ground, they are talking about this distance here. That's 16 feet. She let out 20 feet of string from where she's standing. So she's standing over here, flying her kite with its string. That is 20 feet of string. Now we'll assume that the string is taut, even though I drew it a little curly. And I want to know if the kite were to come crashing down to the ground, how far would it land from Laramie? What I want to know is x, and again in this case I'm solving for one of the legs. I am not solving for the hypotenuse, and you need to be very aware of that when you're setting up your equation. Why don't you pause here and take a look at 3 and 4, and then we'll go on and do 5 together. In number 3, I got 15 kilometers, and again you will see that typically we should be using this plus or minus to signify that the solution could be a positive or a negative 15, but we only care about the 15 since we're talking about a distance, and distance cannot be a negative length. In number 4, the key element here is to make sure your 20 stands alone on one side of the equals, and then in fact you're going to subtract the square of 16 from the square of 20, which is going to give you 144. Take the square root. It is positive or negative, square root of 144, but we only care about the 12 feet. We are going to do a rectangle problem next, so this should be an easy one for you to draw. The rectangle has a length of 11 feet and a width of 5 feet. I would like to know how long the diagonal is rounding my answer to the nearest tenth. Keep in mind that if the question asks for an exact answer, you would not round, you would give simplified radical form. In this case, I am in fact finding the hypotenuse, so I'm going to plug right into my Pythagorean theorem equation with x squared being my c, and then I'm going to choose a to be 5 and b to be 11. It doesn't matter if you do the opposite. I'm going to get x squared equals 146, which is 25 plus 121. So x equals positive or negative square root of 146. Well, I only care about the positive, so x is approximately 12.1 feet. You should round that correctly. This is 12.083, but they want it to the 10th, so I have to remember peek around the corner and look at that 8, which tells me to round it up. Moving on, we go on to number 6. A plane flies 1.6 miles west, then 1.2 miles south. How far is the plane from its starting point? So I'm going to start my plane here. It flies west, then south, and I want to know this. So why don't you go ahead, plug in, and see what you can do on that problem. Solving for the distance from the starting point, I got 2 miles. I think the next several, you can probably try them on your own, and if you'd like, then you can come back and check your answers. Alrighty, I've got my pictures and all of my work shown appropriately here, and you can check your answers, check your work, and if you have any questions, take special note of that and we can answer them tomorrow in class. Have a great night, everybody. See you tomorrow.